Hello, class. I'd like to talk a little bit about our schedule. I sent all of you an email concerning this schedule. If you look at the original syllabus, we had a couple days scheduled to have off for middle school math B. And I would like to just plow ahead and get done with our particular sections that we have to do and take those 2 days off during the last week of this semester of classes. A lot of students have papers that are due at that point, and they need the extra time then. So just to clarify our schedule, today I'm assigning section 5.4, assigning today, Tuesday, April 21. It's going to be due next Tuesday, April 28. Then, just to make sure we're on the same page here, we'll review this coming Thursday, April 23. So we will have class this coming Thursday, April 23. There'll be no classes the following week. April 28 and 30 will take off. I know it's a little blurred there, so you might have to just hear the words. No class April 28 and 30. We'll have a review on April 23. Our final is Tuesday, May 5 from 9 to 11 Central Standard Time. So if you're in a different time zone, you'll have to adjust. But final is Tuesday, May 5 from 9 to 11. So today, we're looking at section 5.4, all right? There is a couple of formulas that we need to review that pertain to our lesson today. The first one has to do with this problem right here. This is a problem we did back in, I believe, section 5.2. Find the future value when you deposit a particular one-time lump sum at some percentage, compounded, in this case monthly, excuse me, into an IRA and leave it in the account for 25 years. The formula that we need for this one, this is a future value compound interest formula. If you recall that procedure, we're looking for the future value, so that's going to be our unknown. The principal that we're putting in here is $136,236.52. We're taking that times 1 plus I. I, you recall, is the interest rate, which is 0.08, divided by the number of times it's compounded per year, which would be monthly, means 12 times a year. And the N is the number of years times how many times it's compounded. So 25 years times 12 times a year, that's 300. So I'll write this just a little bit larger. I apologize for that. I'm just recopying it. 25 times 12, I believe, turns out to be 300. You would then use your calculator to find this. You would take 0.08 divided by 12, enter, plus 1, enter, exponent 300, enter, times 136,236.52. When you do that, you will get very close to the future value, approximately equal to $1 million. I chose this one-time lump sum so that it would, in fact, produce about $1 million. Make very, very sure you can go from your calculator down to here. Super important that you can do that, okay? That's a future value for a compound interest problem. We would also like to review this problem. for our lesson today. Both of these concepts are used in our lesson today, which is why I want to review them. This time I want to set up a sinking fund for my new grandchild so that the child has some money to buy a house by the time the child turns 25 years old. How much money would I need to deduct from my monthly paycheck that would earn 8% compounded monthly to have $1 million? I chose this million to match up this future value here. I kept 25 years to be the same. I kept the 8% to be the same. This is known as a sinking fund, okay? That formula, you recall, was this one right here. We want this sinking fund to produce a future value of $1 million. So that future value we're looking for the payment that I would have to deduct. My I is the same as I up here. It's that interest rate divided by how many times it's compounded. So my interest rate is 8%. Compounded monthly is going to be 0.08 divided by 12. N is going to be that same 25 years times 12, or 300. Probably should have gone another set of brackets here, but this will work. Over I, which is 0.08 divided by 12. You might want to get this 0.08 divided by 12 as a separate number. It's actually 0.006 repeating. That's what that number actually is. So now I could go to my calculator, listen to these commands. I would start with 0.08 divided by 12, enter, plus 1, enter, exponent 300, enter, minus 1, enter, divided by 0.00666, as many as you can put on your calculator, enter. That will give you that particular amount there. And that basically gives you a payment times some number. All of this, when you put it in, will turn out to be approximately 951.026,396, depending on how many decimal places your calculator goes out. You then take $1 million divided by that number, and you get your payment. Turns out that the payment is $1,051 and approximately 50 cents. So, just to make sure we understand what that 1,051 is about, it means if this grandparent is willing to put in 1,051 per month at 8% for 25 years, when the grandchild gets to be 25, there's $1 million in that account for the grandchild to use to buy a house or do whatever they want to do with that $1 million. These two formulas are going to be used today. Very, very important ones in today's lesson. That's why I reviewed each of those two formulas. Today we're considering an amortized loan. The reason I think this is an important lesson for you is many of you within the next 5 to 10 years are going to be purchasing a home or a house. 99% of the loans are done as an amortized loan. The difference would be maybe if you borrowed it from your rich uncle or your parents helped finance the house or whatever. But for most of you, when you buy a home, you're going to go to some bank or lending institution and taking out an amortized loan. I would like you to understand how this loan works, all right? Referred to as a simple interest amortized loan, okay? Well, to help you understand what is occurring there, let's just say you're buying a home for $150,000. If you borrow $150,000 to purchase that home, the bank wants you to pay back not only the $150,000, but they also want you to pay what that $150,000 could have earned for the bank. Because the bank, if they had not lent you the $150,000, they would have invested that $150,000 to make it grow. So from the bank's perspective, they don't want just the $150,000 that you borrowed back. They want also what that $150,000 could have earned. That's the compound interest formula at work. That would find the future value the bank could have earned if they had invested the set amount. In this case, I just made up $150,000. Then that's the overall amount that you would have to pay the bank back. The 150 plus what it would have earned, which was the future value of a simple compound interest formula. That basically was this type of problem at work. Then you would also use the annuity formula as a sinking fund to find the payment that you would eventually produce to produce the same value that the bank would have earned. What do I mean by all of that? Well, this is what's going on. The bank had a principal of $150,000. I'm just making up that number. The bank could have invested that in a compound interest formula. They would have took that 150, plugged it into this formula, and it would have gotten them a future value of the 150,000. You, on the other hand, are looking for a payment. This would become your house payment. You would be looking for a payment that would be a sinking fund. So it's going to be, in this case, 1 plus I. This is that same formula that we just got done working with, over I. Listen now, some payment that you put in once a month would start calculating a value that would give you a future value. This was a one-time lump sum that would earn interest per month to give it a future value. We want these two future values to be the same. We want them to be equal. That means we want these two formulas to be equal. That's our formula that we're going to be needing. I'm going to put it in a little bit better form here so you can copy it down. Here is that formula for a simple interest amortized loan. This becomes your monthly payment, your house payment every month. This principal is the amount that you have borrowed. It's the future value of the loan amount. The left side is the future value of the annuity, we want them to become equal. That's when they finally become equal, the house will be paid off. This payment is your loan payment, or you would refer to it as your house payment, your monthly house payment, the loan payment. I is the periodic interest rate. That's both of these I's as well as that one. It's always the interest rate divided by how many times it's compounded. Most of the time, these are monthly payments, so it's interest rate divided by 12, interest rate divided by 12, interest rate divided by 12. N, that's these two N's right here, are both the same. It's the number of payments times the number of years. Number of payments every year times the number of years. So if it's compounded monthly, it's 12 times the number of years. P is the present value or the amount that you want to borrow. So this formula helps us produce our monthly house payment. If you need to pause this to write all this down, please do so. Very important formula here. You'll have it on your notes when you take your final exam because you'll have a cheat card, but you'll need to be able to write that formula down and to use it. Let's take now an example. Again, pause this if you don't have it written down. Okay, imagine I want to buy a house, kind of a starter home. It's a relatively cheap one, $140,000. And I want to put 20% as a down payment. Okay, then I want to finance the remaining amount or the other 80%. So if I put 20% as a down payment, 140,000 times 20% will give you, 28,000. That's the amount that you're putting as a down payment. What do you have left to borrow? You got to take the house price minus your down payment. That leaves you the amount that you want to borrow, which in this case would be $112,000. So you want to finance the remaining amount. You want to finance the $112,000. You're going to finance that at a simple interest amortized loan. That's the formula we've been working with. 6%, and you want to pay off your house in 25 years. We want to find the following. First of all, our monthly payment. Okay, well, our monthly payment I'll come back to that. But our monthly payment is, we have to first find out how much I need to borrow. So I take 20% of 140. I did that right over here. And I subtract that answer to get 112,000 that I need to borrow. My I, I've just calculated this separately. 6% interest, compounded monthly, so it's 6% divided by 12. That I is 0.005. The N, I've just compounded it 12 times a year for 25 years is 300 monthly payments. So here we go now with this formula. Here's the formula that we would have had. I'm going to slide this down a little bit. So I'm going to look for the monthly house payment. I'm going to take the I value, which is 0.05, put it in here as well as over here. The N was 300. So if I put those values in, again, now make sure you can go from your calculator right here down to this 692. Again, just a quick review of that. It would go 0.005 plus 1, enter. Exponent 300, enter. Minus 1, enter. Divided by 0.005, enter. And you should have about 692, etc. To go from here to here on your calculator, you're going to go 0.005 plus 1, enter. Exponent 300, enter. Times 112,000, enter. And you should get that number, which is about 500,000. That is, by the way, what 112,000 would have earned. 112,000 would have become about 500,000 in 25 years. You then divide this 500,000 by 692 and you get your monthly house payment, $721.62 every month. That's how to use this particular formula. Make sure that you can do this type of problem, that you can take some amount that you're going to borrow, in our case, $112,000, at some interest rate, 6% monthly for 25 years, as we did right here. Okay? We just found the monthly payment. Now, we would like to find out what was the actual total interest that we ended up paying. Okay? Well, to find that total interest, you recall we had to make 300 payments. 300 was 12 times a year for 25 years. We made 300 payments. This was the payment we calculated, $721.62. Well, if you take 300 times that, this is the total amount that you're going to pay in 25 years. Notice, you recall again, you borrowed $112,000. You're going to be paying back $216,486. So why are those different? It's because you don't pay back just what you borrowed. You pay back what you borrowed plus interest. That's why here you end up paying more than what you borrowed. That's standard procedure. So the total interest is going to be this total amount you paid minus what you borrowed. So you ended up paying this much back in 25 years. You borrowed $112,000. It meant you paid $104,000 in interest. Notice you almost paid for your house twice. If it would be about at 7%, had it been at 7% for 25 years, you probably would have paid back about $110,000 to $120,000. You would have paid for it twice. That's standard procedure. That was the total interest. Then you also could have calculated what would the interest be if the payback time were 33 years or 15 years. Well, if you were to do it for 33 years or 15 years, you would have gone back to here. And rather than the n being 300, if it had been 33 years, you would have had n to be 33 times 12. That would have been in place of the 300s. That would have changed it some. You would have gotten a smaller payment. The smaller payment would have been great every month, but you would have had to pay for it for 33 years rather than 25 years. That's the downside. It also means you would end up paying more interest. If you had gone 15 years, then this n would have been 12 times 15. That would have been a smaller number than 300. It would have given you a more expensive house payment, maybe around $1,000 or $1,100 per month, but then you would have had it paid off in 15 years, and you would have paid less interest. Listen carefully. Here's Dad speaking again. You obviously got to be able to afford your monthly house payment. However, if you can set it up on fewer years, you will end up paying far less interest. But it's how much of a house payment can you handle every month? That's always a tough call. Most banks will estimate that the house payment you should have is about 1/4 of your take-home check or checks if you are married. Take your 2 take-home checks, sum them up, take that times 0.25 or 1/4. That's about what your house payment should be. Again, for some people, you have to go 33 or 25 years. But for others, you might be able to pull it off in 15 years. You'll end up paying a lot less interest if you can do that. Let's rework a problem. That one there. We want to first find our monthly payment. So that's my goal here, find the monthly payment. Our formula, you remember, is the payment times parentheses 1 plus I raised to the nth power minus 1 over I is equal to our principal, the amount borrowed, times 1 plus I raised to the nth power. Well, I'm looking for the payment. I is my interest rate, and if it doesn't specify how many times it's compounded, you can always assume it's compounded monthly. Don't think that was here, but it said monthly payment. That is by far the most common. So that I then is my interest rate divided by 12. So that's 0.10 divided by 12. The N is the number of times compounded per year, monthly 12, for how many years? So it's 12 times 10, or 120. P is the amount that I'm borrowing. I'm borrowing 80,000. This 1 plus I is the same as it was over here. 10% divided by 12. And it's the same 12 times 10 for N as it was here. I forgot my minus 1. Forgot to plug that in over here. Just filling in those other amounts. The N then is the same 12 times 10 or 120. Again, for calculator purposes, I think sometimes it's easier to calculate this fraction if you're not really comfortable with the calculator. Calculate that amount first, and then write that amount in for all of those. If you do that division, turns out to be 0.00833 repeating. I'm just going to rewrite that in here for some of you if the calculator exercise is kind of a challenge. So instead of this fraction, I'm going to put in that decimal. And I'm going to do the same thing over here. For some of you, that will make this just a little bit easier. you want to be able to go from this expression down to one number. So you would take 0.008333 plus 1, enter, exponent, 120th, enter, minus 1, enter, divided by 0.008333, enter. And if you do that, I believe you'll end up with approximately 204.84499. If you have a few decimal digits at the very end that are different, it's a rounding issue with your calculator, not a big deal. Here you would go 0.008333 plus 1, enter, exponent 120, enter, times 80,000, enter, and you would have your amount. It'll be approximately 216,563.32. You then divide this 204 into that number, and you get your monthly house payment. Turns out to be $1,000, 57.65. Again, if you're slightly off on the cents, don't worry. That's a rounding issue, not a problem. Fairly high house payment. It's because we did it in 10 years, and it was a very high interest rate. Right now, you can borrow for houses at 2 to 3%. Back in the 80s, it was oftentimes 10 to 15%. Makes a huge difference on your house payment. You are living at a very fortunate time to be coming out of college in the sense that you can buy loans or buy houses for very low interest rates. That makes houses a very good investment for you from age 22 to 30. So borrowing money for a house is probably a wise move for most of you. Next, we'd like to find the total interest paid. Okay, well, the total interest paid, is going to be total interest. It's going to be total of all payments minus the amount borrowed. Okay, total interest minus the amount borrowed. We said it right here earlier. Total payments minus the original principal. So in my case, for this problem, the total payments of all payments is going to be, I'm going to have made 120 payments, each of which were 1,057. So 120 times 1,057.65. That's the total of all my payments, minus the amount that I borrowed, which was $80,000. So if you do that, you will end up with approximately $46,918. And again, you can work that on your calculator, but check that out. This is the amount of interest you would have paid. Not so terribly much because you put it on a pretty aggressive payback, 10 years or 120 months. That's why you didn't pay as much interest. Okay? Now, the next thing we would like to do is to set up an amateurized schedule for the first 4 months. All right? Remember again, from this, our house payment was that amount. That's the amount of house payment, And remember that we borrowed 80,000. Okay? Try to remember those two numbers as I go to this next picture. The amortized schedule. We're going to be calculating these for the first 3 or 4 months. The bank actually calculates them for all the months that you pay off the loan. In this particular problem, you remember it was 10 years or 120. So the bank would do this for 120 months. I would like you to be able to do it for the first 3 or 4. Listen carefully. The main purpose of this is to help you understand what happens to your monthly payment. I want you to understand an amortized loan. That's what it's about. So here we go. We have 5 columns. Payment number, it's like maybe the first payment, second payment, all the way up to the 120th payment. The principal portion is how much of your monthly payment goes to reduce your principal. The interest portion is how much of your monthly payment is used up in interest for that month. Total payment is the same, which we just got done calculating. Balance is how much you continue to owe. So here we go with this example. You remember we borrowed $80,000 for 10 years. We figured out our payment. Right here it was. The first payment and all of your payments for 120 months in a row would be $1,057.65. But now listen carefully. This is an important understanding of what's going on. You owed $80,000. When I make my first payment, they don't take all of this payment and subtract it from 80,000. No, rather what they do is they first figure out the interest on 80,000 for 1 month. So they take that 80,000, they take it times your interest rate, which was 10%, and it gave you 800. That's how much interest for a year. We want it for 1 month. So I would take that 800 divided by 12, and that's where they get this interest amount, $666.67. That's the amount of interest for 1 month on $80,000 at 10%. They're going to take this interest amount, and that's going to get used up first from your payment. So you made a payment more than that monthly interest, but the interest goes back to the bank first. What's left over, in this case, take this number away from 1,057. This is how much is left, $390. That $390 gets applied towards the principal. So I take that $390 and I subtract it from 80,000. 80,000 minus 390 is going to give me that amount right there. That's my new balance that I still owe after 1 payment or 1 month. Okay, now watch what happens. The second payment, notice these never change. These payments are like clockwork for 120 months in a row. But this time, I don't have quite as much interest. The reason that the interest portion is less is because the interest is on this amount right here, $79,609. So rather than taking 80,000 times 10%, we take 79,609 times 10%. It'll be a little smaller than 800. We divide that by 12, and we get this number right here. I'll write that over here once. That would look like 79,609.02 times 10%. And I'm going to take that answer. I'll put that down here for the first one. We won't do this for all of them, but I want you to make sure that you get this down. That was 7,960 I guess I should have been able to do that. 0.902. I'm going to then take that number, divide it by 12. That gives me my interest portion for that month. That's this $633. You've got to do that every time to get this number accurate. This number then gets subtracted from your payment. Notice it's a little bit less interest, so the amount left is a little bit more. Rather than $390, it's $394. So you're going to take $394 and subtract it from $79,000 to give you now the balance you still owe. So this amount keeps getting smaller. We keep doing that. So let's just again go through the next one real fast in words. House payment stays the same, like clockwork. But the amount of interest, how do I get it? Take the previous balance times 10%. Take that answer divided by 12. This time it would be $660 of interest in 1 month for that principal. Subtract that from my house payment, gives me the amount left to reduce my principal. Take $397, subtract it from this, gives me my new principal. Go to month 4. House payment the same. How much interest? Take the previous balance times 10%. Divide the answer by 12, gives you the new interest for that month. Take that interest, subtract it from your house payment. This is the amount that gets applied toward your principal. So you take the 400, subtract it from that number to give you this number. Okay, you keep doing that, et cetera, et cetera, et cetera. Now that may look like it's nice and easy, but keep in mind that's every month for 10 years. When you get to the last month, 120th payment, notice again your house payment stayed the same, nothing changed there. But notice that your ending balance is back down to 0. That means you don't owe anything. You paid off your house. The previous balance, whatever it was, would have been taken times 10%. That answer divided by 12 turned out to be $57 interest the last month. Look at your first month, you paid $666 interest. The last month you only paid $57 interest. That's because this amount was much smaller. That left quite a bit more to be applied toward your principal. A full $1,000 got knocked off the principal to get it down to 0. Excuse me, I'm expecting that you can make up the first 3 or 4 monthly payments. Don't be afraid to review this process. This number stays the same. All the other numbers change, and you got to know how to calculate those numbers. By doing this, you start to understand how the amortized loan works. Notice early on you pay more interest than you do pay off your house. At the end you pay very little interest, and a much more per month gets used to pay off your house. That's standard procedure, right? We got one more concept left over, and it's kind of a challenging one, to be really honest. Go ahead and read that problem once. This actually is fairly common. A young couple buys a house for whatever amount. Maybe it's 100,000, maybe it's 500,000. They set up an amortized loan. They probably set it up for 25 years. That's pretty common, maybe the most common of all. But after a certain amount of time, they either come into some particular amount of money, a huge bonus, or more likely, maybe their parents passed away and they inherited some money. They decide to take part of that inheritance and use it to pay off their house, and basically then no longer have a house payment every month. That's a very common procedure. Not all couples do that, or not all individuals do that, but a lot of them do. Well, the key then is we borrowed $100,000. We started paying off that $100,000. We did it slowly every month. You remember, basically, that would come from something like we just got done with. So after a certain amount of months, maybe by the 40th month or maybe by the 60th month, 60 months would be 5 years, we got some inheritance and we wanted to pay off whatever was still owed. That's what this problem is about. Okay? So what I'm going to do here is I'm going to first find my monthly payment. Then I'm going to find the unpaid balance. The unpaid balance are these numbers right here. After so many years, how much is still left to be paid off? That's the unpaid balance. When you get your house paid off, the unpaid balance is 0. But in the meantime, you still owe some particular amount. That's the unpaid balance. That's what we're looking to calculate. In this case, we're looking for that after 5 years. Okay? So first we got to find this monthly payment. I put it on here. This is our formula for that monthly house payment. We borrowed $100,000. My interest rate, if you remember, was 6% per month. Well, if I take that 6% divided by 12, that's where I get my monthly interest rate. That's the I. All three places, that I is 0.005. It's your annual interest rate divided by 12. We're looking for, what is our payment? Sorry, I got to jump back and forth here. We're looking for our payment for a 20-year payback. Well, a 20-year payback means 12 times 20. 12 times a year for 20 years means I'm going to be making house payments for 240 times. So these ends are both 240. 12 times the number of years. Then I need to take this whole set of numbers, make it into one number, and this whole set of numbers. So here I would go 0.005 plus 1, enter, exponent 240, enter, minus 1, enter, divided by 0.05, enter, and I get that number. Turns out to be about 462.04. And again, be so sure that you can do this on your calculator, because if you can't get from here to here, you have no chance of making it through this problem. So practice that so that you can do it really well. Over here, 0.005 plus 1, enter. Exponent 240, enter. Times 100,000, enter, and you get that number. Again, be very sure you can do that. I'm going to do this one right here. So I'm starting with 0.005, add 1, plus 1, enter. Gives me all of that. Exponent is this dash one right here. So exponent 240, enter. That gives me all of that. Times 100,000, enter. That's where I got this 331.020.45. Again, redo that as often as you need to get to these two numbers. Then you divide by the 462, and here's your monthly house payment, $716. That was part A. the monthly house payment. $716.43. If you need to pause here to write things down, please do so. What is the unpaid balance after 5 years? Okay, unpaid balance after 5 years. Well, this is a tough concept. I will try to explain it. A little bit challenging. The unpaid balance, notice these are the two parts from my formula that we were using, right? The formula that we were using is this one right here in the box. This was our formula. When these two become equal, the house is paid off. If I pay this $721 for that amount, it'll equal the $112. This side starts out bigger, starts out at $112, but after 20 years, 25 years, it would be equal. We would have paid it off. Notice these two expressions are set equal here. But now when I'm finding the unpaid balance, here's a new formula. It's the same two things, but I'm subtracting them. Here's what's going on. Why is this? This is the amount the bank could be earning if they took that money you borrowed and invested it themselves. This is the amount of money you are paying back. Eventually, this amount of money you pay back equals the amount the bank could have earned. When this amount finally gets big enough to equal that, then the difference is zero and you've paid off your house. But in the meantime, this amount is bigger than what you're paying back. The reason it's bigger is it starts off at $100,000 or $120,000, whatever you borrowed. This starts off with your first payment. This starts off much smaller, but it gains ground. It gets bigger and bigger and bigger, and eventually it catches up to what the bank could have earned. That's provided your payment is calculated accurately. The difference then is your unpaid balance. Here's the part, be really, really careful. The N in the number of payments from the beginning to the loan to the present is what you use when you find your unpaid balance. These two N's are different than when you're finding your house payment. When you're finding your house payment, you take 12 times the number of years you're going to pay it off. But when you want the unpaid balance, you're only going partway through that amortized loan. You're going to a present value. In this problem, it was 5 years. Well, 5 years of 12 payments means 60 payments will have been made. That means rather than this being the total length, the ends will become 60 because that's how many payments you would have made in 5 years. So watch now the substitution. I put it in red because here's an easy place to make a mistake. When you want your unpaid balance, this end is 60, this end is 60. 60 was because you looked at it after 5 years. If it would have been unpaid balance after 4 years, it would be 4 times 12. These would have been 48s. If you had looked for unpaid balance after 7 years, it would be 7 times 12. That would have been 84. Again, that would change. But now you calculate each of these and you subtract them this time. Remember, I'm subtracting. That amount gives you your unpaid balance. So you had borrowed here $100,000, and after 5 years, you would still owe $84,899. That's still a large amount after 5 years. It's because most of those first payments, you remember, goes toward interest. It doesn't reduce your principal that fast. Okay, let's try this problem one more time from the very beginning. I'm going to let you read that a moment. you would be expected to be able to find an unpaid balance after a certain amount of years. Okay? First thing I got to do is find my house payment. My monthly house payment. That formula, here again, we had it earlier today. It was the following. Your payment one plus I to the nth minus 1 all over I. My pen is getting kind of light. I hope it doesn't die on me. Principal amount borrowed 1 plus I raised to the nth power. I'm looking for my house payment first, so I'm missing this amount. My I can either do it separately, 0.08 divided by 12, and that might be maybe the easiest way to write it down. So 0.08 divided by 12, I think we already did this, 0.006 repeating. That's your I value, 0.006 repeating. That's going to be for all of those I's. N was 12 times a year for 30 years. So N starts out here. Notice this is 12 times 30 or 360 months. Same I that I had here, 0.006 repeating. That is equal to the amount that I borrowed, 50,000, right up here, times 1, same I that I've used in these other two slots, 0.006, repeating. Same N, 360 payments. Okay? You need to calculate each of those down. This one right here turns out to be, I can barely read my writing here, but I think it's 1490.3596. This side is 546,786.48. When you divide, you get your payment to be $366.88. Really small house payment. This was a very cheap house, and you've spread it over 30 years, so you get a low payment there. Okay? Try to remember those numbers now, because now we're going to find the unpaid balance. Notice to find the unpaid balance, our first step was to find our house payment. The house payment, $366.88. Okay? Then we're going to go to, remember these numbers now. Okay? We're going to go to our unpaid balance formula. Okay? The unpaid balance formula it was equal to the difference, you remember, minus the difference, which was your house payment, times 1 plus I to the n minus 1, all divided by I. Okay? Going back, our house payment was $366.88, I believe. That's going to go right in there. 366.88 The amount we borrowed was $50,000. You remember our I we found earlier to be 8% divided by 12. So I here was 0.08 divided by 12, which we got to be 0.006 repeating. That's going to go in for all of those I's. 0.006 repeating. 1 plus 0.006 repeating. 0.006 repeating for the I down there. Now watch carefully. The N. Last time it was 12 times 30, 360, when we calculated our payment. Don't miss that. That was the full length of the loan. 30 years times 12 times a year, 360. But now we want the unpaid balance in 10 years. After 10 years, what would the N have been? Well, the N would have been 12 times a year times 10. The N would have been 120. So this N is 120. That N is 120. Very, very important difference. Remember, when we calculated our payment, the N was 360 for 30 years. We're looking for the unpaid balance after 10 years. 10 years is going to be 12 months a year times 10. Very important difference. You need then to calculate each of these. When you do that, this one will turn out, the first one will be 110,982.01, I believe. This one, when you calculate it out, will be 67,119.25. When you do the subtraction, you end up getting 43,862.76. That is your unpaid balance. So if you have a lump sum available of $43,860, you can pay off your house at that point in time after 10 years. Basically, 2 steps to this. Step 1 was find your house payment, which we did. Step 2, use your unpaid balance formula to find the difference between the value of the loan and how much you've paid off. That difference is what you still owe or your unpaid balance. That is all I have for today. You have section 5.4, sign today, due next Tuesday. We'll have a review this coming Thursday, and then the following week we'll take off, and then we'll have our final. Have a good rest of your day.